All right, chapter 14. Okay, first thing. Let's review on these identities. CSC means what? 1 over sine. What's the name of CSC? Cosecant. Very good. Okay, cosecant if you forgot. Okay, so a lot of people are still saying cos-tan. CSC, I don't know, sec. No good. Okay, so it's called cosecant. Okay, SEC means what? Secant. And secant is what over what? 1 over sine, cosine. 1 over cosine. Tangent. We are on the reciprocal identity right now, so we're talking about reciprocal. Okay, 1 over something. So tangent is 1 over what? 1 over something. 1 over... Yes, tangent is sine over cosine, but it's the same as 1 over what? No, tangent is not 1 over tangent again. Huh?
1 over cosine over sine.
Yes, it is 1 over cosine over sine. What is cosine over sine? Yes, cotangent. Okay, tangent is 1 over cotangent. Now it should be pretty easy to go backwards now. So secant is this. Sine is the same as 1 over what? Huh? Cosecant. Yes. Sine is the same as 1 over cosecant. Okay, so we can go backwards, forwards, and backwards with sine and cosecant. How about cosine? 1 over what? Secant. Not sec, secant. Cotangent is 1 over what? Tangent, good. All right, now, of course, we remember that there are 2 other ways to talk about tangent and cotangent. That has nothing to do with reciprocal. So tangent is also what function over what function? Ooh, sine over cosine. Okay, so some of you made this mistake on the test. So you thought tangent was cosine over sine, so you graphed the wrong thing, and then your whole graph is wrong. So please remember, cotangent is what? Cosine over sine. Cosine over sine. All right, let's look at our unit circle. Okay, we're gonna do a mini proof here. Let's say that we have this 30 degrees here. All right, 30 degrees, let's draw a right triangle from this 30 degrees. So this line goes to the edge of the unit circle, and we draw a straight line down. This creates a 90 degrees, and then we form a right triangle, right? Let me ask you a few questions. Hopefully you still remember your unit circle. How long is this hypotenuse? This is an easy question. 1. Why? Hypotenuse? It is 1. Why is it 1? Because the radius is 1. It's a unit circle. Unit circle has to have a 1 in the radius. All right, let's try to remember this part. How long is this x part? Remember, x means cosine. So how long is cosine 30? Square root 3 over 2. Okay, how long is the y direction then? 1/2. Now, this is a right triangle, so we can apply Pythagorean theorem, right? Pythagorean theorem says a squared plus b squared is equal to c squared. So we can say that a is the bottom part, so square root 3 over 2. B is the 1/2 part. And that both of them squared, the sum of that should equal 1 squared. Okay, let's check. See if that's true. Square root 3 over 2 squared is what? 3 over 4. Okay, so hopefully you're kind of doing some of these last semester practices. Okay, so 3 over 4. 1/2 squared is what? 1/4, very good. 3/4 plus 1/4 is equal to what? 1, or 4 over 4, which is 1, right? So this does work. Yes? Now, another way of saying this part is square root 3 over 2 is saying that this is cosine 30 degrees, right? Because it's at 30 degrees and it's the x direction, so that is cosine 30. Yes? Okay, and then so we can say this is sine 30 degrees. Okay, everyone please concentrate up here. Okay, so the y direction is sine 30 degrees. So now what we can do is instead of saying square root 3 over 2 and 1/2, we can just say it's cosine 30 degrees squared plus sine 30 degrees squared is equal to 1. So what I'm doing here is just replace that, because square root 3 over 2 is cosine 30. 1/2 is sine 30. Okay? Are you guys good? Now, I don't really have to draw this triangle. I can draw another triangle here, right? The 45 degrees. And then I can do the same thing. And because it's a right triangle, it will always work. Therefore, I can say that this is cosine of theta. So hopefully you remember theta. Cosine theta, theta is an angle. So cosine theta squared plus sine theta squared is equal to 1. Okay, so this is the identity. You have to memorize this. And when I say you have to, you do have to. This is a very, very basic identity. You have to memorize that. Now, in your math book, you will almost never see this because they just don't write it that way. Okay, what you will see is this. Okay, they mean the same thing. That square inside just means the whole thing squared. You have to know they mean the same thing because on your calculator, there is no square button inside of the sign. So then you may get confused, like, how am I supposed to put this in my calculator? You have to know it's the same as that, so then you can put it in your calculator. Okay? So every year someone tries to type that in and then says, oh, what? My calculator says error. You have to change it back to this. Okay, so essentially what you're gonna see on in your math book is cosine squared theta plus sine squared theta equals 1. So I have a little comic here to, it's like a very nice romantic comic. I wish I were a sine square and you were a cosine square. So together we would be 1. So cute. You guys can like give it to your potential mate. Okay. All right, so sine squared theta plus cosine squared theta is 1. Okay, that is the first identity. We always start with sine squared. You can do cosine squared. It doesn't really matter. Okay, sine squared plus cosine squared is 1. All right, second identity. Second identity is related to the first one, and it's very easy. So what you do is you divide everything by sine squared. Okay, so basically we're dividing everything by sine squared so that we're not really changing the equation. We're just manipulating it. So we're going to divide everything by sine squared. All right, so let's look at this together. Sine squared over sine squared is what? 1. All right, cosine squared over sine squared, you may not know. Let's take out the square. Cosine over sine is what? Cotangent. So cosine squared over sine squared is cotangent squared. All right, 1 over sine squared. Let's take out the square. 1 over sine is what? Cosecant. So then 1 over sine squared is cosecant squared. Okay, so this is the second identity, but it's very easy if you just remember sine squared plus cosine squared is 1. Are you guys good? Questions? No questions? Okay. The third one is equally similar. So instead of dividing by sine, we are going to divide everything by cosine. Divide by cosine squared, divide by cosine squared, divided by cosine squared. All right. Sine squared over cosine squared. Now you know the trick. So sine squared over cosine squared is what? Tangent what? Tangent squared. All right. And then cosine squared over cosine squared is 1. And someone besides this area. 1 over cosine squared, someone from here. Yes, secant squared. Secant squared. Okay, these two are harder to remember, so you may want to come up with your own ways to remember this 1cc, and this one's a little bit harder, so I don't really write it as tangent squared plus 1. I just write it as 1 plus tangent squared. So they're more similar, like they all kind of look similar. So 1cc and 1ts. I don't know. Like over the years, people have come up with different ways of naming this. So like 1 concrete, what was it? I don't remember. I don't remember. They were trying to put some English stuff in there. But anyways, I don't remember. But try to come up with your ways of remembering 1cc, 1ts. All right. Next. We're going to do algebra proofs now. Algebra proofs are not the same as geometry proofs. I think it's easier, or it's easier in idea, but it requires you to think outside the box because there's nothing to look at. You just have to think, like, what can I do to make this work? Okay, so when we verify an identity, we can only change one side, and that side is the left-hand side. So we need to only change the left-hand side and make it look like the right-hand side. All right, so let's go ahead and look at this first one. Okay, so 1 plus tangent squared is secant squared. We need to show that it works. Okay, we can only change the left-hand side and make it look like the right-hand side. Obviously, that is the identity, but we need to somehow prove it. Okay, so somehow we need to change 1 plus tangent squared so it looks like the right-hand side. Okay, I'm going to kind of show you how to do it first, and then you can kind of follow these tricks. Okay, tangent squared is the same thing as what over what? Sine over cosine. So whenever you can't figure out what to do, you always change everything to sine cosine. So this is 1 plus sine squared over cosine squared. All right, somehow this needs to look like secant squared. So let's remember algebra from last semester. What can we do to combine them together? Because we have basically a whole number and a fraction. Someone said something that was correct. Make them what? Same values in what? Secant? No. What can we do? Okay, so for example, if I have a 1 plus 1 over x, how do I combine them together? Yeah? Times what? x over x, we have to have this common denominator. So we have to multiply by whatever the denominator is, top and bottom, okay, numerator and denominator. So we need to multiply by cosine squared, cosine squared. Okay, so this left-hand side becomes cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta. Now what? Add them together, so the numerator becomes cosine squared theta plus sine squared theta over cosine squared theta. Please don't add the denominator twice. Now what? Cosine squared plus sine squared is 1. Okay, so remember last page. Cosine squared plus sine squared is 1. 1 over cosine squared. Remember, our destination is secant squared. How do we change this to secant squared? Yeah, it is already secant squared, right? So hopefully you realize that 1 over cosine squared is secant squared. Okay, so we're done. We changed the left-hand side so it looked like the right-hand side. How do we do that? First, change everything to sine and cosine and try to manipulate as much as possible to look like the right-hand side. Yes? Cosine squared plus sine squared is 1. Yeah, from the first page. All right, let's have you guys practice. This one. So this one's very similar, so you should be able to apply it almost exactly. So go ahead and try that one. This 1 plus cotangent squared is cosecant squared. Okay, this one should be pretty easy. So 1 plus cosine squared over sine squared. Okay, common denominator. So this becomes sine squared over sine squared plus cosine squared over sine squared. Of course, if you can do all this in your head, please skip steps. Okay, sine squared plus cosine squared over sine squared. So this is 1 over sine squared, which is cosecant squared. All right? Okay, now so these are the very easy ones. Let's do harder ones. So verify that this looks like this. Okay, so this is where you need to kind of think outside the box a little bit or just try something. Sometimes you don't know, just try something. Left-hand side only change the left-hand side. What should we do? Give me some ideas. Good. Make tangent square over equals to sine squared over cosine squared. Okay, please don't be scared to try something and not work because that's just kind of part of life. You gotta try. Oh, that didn't work. Go back. Try again. Okay, so don't be afraid that you cannot get the answer in one step. Okay, what's next? Good? Okay, make them into one fraction and then kind of hope for the best. Hopefully we are on the right track, sorry. Are you guys okay if I take a shortcut and not write everything else? So I'm going to combine the two fractions together in one go. That way we don't write this over and over. Yeah? Okay, the whole denominator is cosine squared, right? So I know the whole numerator is going to add together. So I'm just going to write it together without doing another step. Okay, are you guys okay with this? You know how I got to that step? Yeah? Okay. Now what? So look at your destination on the right. The right-hand side should be tangent squared plus sine squared. That doesn't look somewhere close, but it's okay. Keep going. What should we do? Try something.
Take the sine out.
Okay, good idea. Take sine squared out. So this is 1 minus cosine squared over cosine squared. At this point, you should try to look at the right-hand side and say, am I getting close? Am I not getting close? Is there any way to get there? Aaron says yes. It's true. Yeah, the end is very close. I need a sine square, which is here, but I don't see the tangent square. Or do I see a tangent square somewhere here?
You can change 1 minus cosine square to sine square.
Yes, that's the key, but it's a little bit fast. Yeah.
Oh.
If you factor out sine square, that's 1. All right, so at this point, we need to do this tricky thing on the side. Okay, so sine squared plus cosine squared is 1, right? This identity is not fixed. We can move it around to fit the things that we wanted to fit. So can you see where this 1 minus cosine squared might come from here? How? Yeah, so what we can do is subtract cosine squared on both sides. So this identity is not a fixed identity. So basically, it's not stuck. It's not only one way I can use it. I can move it around any way I want, as long as both sides are equal, right? Hold on, Luke, let me finish writing and I'll ask you. Yes, question?
How did you get sine squared theta minus sine squared theta?
Oh, you factor out the sine square. So whenever you see something that repeats, it's almost a hint. Ooh, factor. So you see sine square is repeating. I'm going to take out sine square. So that taking it out means dividing. Okay, so that sine square, I take it out, and that part becomes a 1. This leftover part is a cosine square. Yes?
Wait, so how is cosine squared negative and not the 1?
Dividing by sine squared, this is going to be 1, a positive 1. And dividing this by sine squared, the sine squared comes out, the negative stays.
Oh, okay.
All right, 1 minus cosine squared therefore becomes sine squared. Are you guys okay? So you're going to have to move things around like that in order to solve some of these problems. So sine squared theta, 1 minus sine squared becomes sine squared now, and then that's over cosine squared. All right, how is this going to equal tangent square sine squared? Yes, okay, this is the place where please don't make this mistake. Sine squared over cosine squared is tangent, right? Don't use that cosine square again, okay? It's not a common denominator. It's just a denominator for one of the factor. Okay, so this is this, and you are done. Okay? All right, so for example, 2x over, let's say, y. This is not 2y times xy, okay? Not the same. All right, so please don't give this denominator to everybody. Yes, this is a common mistake, and then people can't figure out how to get back. Okay, let's have you guys do an easy one. Hint, what should you do first? Take out a secant. Anytime you see something repeats, that's a hint factor. Okay, some of you are really stuck. I suggest that you come break time or lunchtime or something like that. What happens is that if you're not used to seeing these as individual variables, so this is really saying like x squared minus x squared y squared. We got to change that. So then you're just going to take out x squared and it becomes 1 minus y squared. If you cannot see that, then you got to come in for some more practice, because these are just variables and you got to be able to just see it. Okay, so this becomes secant squared times 1 minus cosine squared. Okay, secant squared is the same as 1 over cosine squared. And then I'm not changing anything here. So then we already know 1 minus cosine squared from the previous example, that is sine squared. So this is tangent squared. All right. Okay, so your homework is to practice this. Okay, so there's going to be a few where you have to just change this way, that way, and then so to make it work. If you are stuck at any time, please let me know. Okay, don't get stuck at home by yourself.